This problem says, let R be the region in the first quadrant bounded by the x and y axes, the horizontal line y equals 1, and the graph of y equals root x minus 1, as shown in the figure above. What is the volume of the solid generated when the region R is revolved around the y-axis? Okay, so we're revolving it around this axis. It's like this anchor-looking region. When we revolve it, it'll make a solid that has volume. Now, if we're going to revolve it around the y-axis, that's a vertical axis, in order to use one of the methods we've learned, then we need to draw a rectangle from the axis of rotation perpendicular to the axis of rotation, okay, to our curve. So if I imagine just rotating this one disk, or this one rectangle around the y-axis, it's going to make a disk. Okay, so this will be the disk method. Okay, that disk has a little bit of thickness. Now, I drew a horizontal rectangle. If you drew a horizontal rectangle, you're committed to this being a dy problem. The thickness of the rectangle is dy, and that ends up being what this little, the height of this little disk is. And then we just need the radius. Once we know the radius, then what we say is that the area, and we technically say, the volume of this disk, we call that dV. It's a small change in volume. As you move like along the y-axis on this solid, right? You gradually, you're moving through, and there would be a little change in volume, and that is pi r squared, the area of the face, times the height, which is dy. We need to find an expression for r. Now, r is this. That's a horizontal distance, so I need to basically subtract the x-coordinates of these 2 points here. What are the x-coordinates? Well, I know I'm on the curve y equals root x minus 1, but that's not, okay, we're not going to use that. We don't want the y, we have to name all the points in terms of y, so I need to name the x-coordinate in terms of y. Right now I have the y-coordinate in terms of x. So what I need to do is I need to write y plus 1 equals root x, and then when you square both sides, now I know that any point on the curve, the x-coordinate can be named y plus 1 squared. So this is y plus 1 squared is the x-coordinate, and the y-coordinate is just y. And then this point here, it's the same height, and it has the x-coordinate is 0, so its coordinates are 0, comma y. Again, subtract x-coordinates, right minus left, y plus 1 squared minus 0 is our r. Okay, and so now I have that a little change in volume. It's equal to pi, and my r squared would be, so let's be clever here. It's r squared. It's y plus 1 squared, so that's y plus 1 to the 4th. And now what I need to do is I need to sum up all such disks as I draw rectangles, or I rotate rectangles, as y goes from 0 all the way up to 1. And so that tells me that my volume is the integral from 0 to 1. Pi, I'm going to put out here, y plus 1 to the 4th dy. So that will give me the volume. If you look, they actually want us to compute it, so we're going to use the fundamental theorem. This is pi, and then this is the antiderivative of y plus 1 to the 4th is 1/5 y plus 1 to the 5th integrated from 0 to, or evaluated from 0 to 1. If you plug in 1, you get pi times, so we get pi, pi times a 5th, I'll call that pi over 5. If you plug in the 1, you get 1 plus 1 to the 5th, which is 2 to the 5th. Okay, minus pi over 5. And when you plug in 0, you get 1 to the 5th. Okay, so this is 32 pi over 5 minus 1 pi over 5, which is 31 pi over 5. And that is answer choice B.